So this is one additional example from section 15.3, double integrals in polar coordinates. In this example, we need to calculate the area of a region that lies inside the quadrate r equals 3 plus 2 sine theta and outside the circle r equals 2. So in the solution, we let the circle call it r1, so r1 equals 2. And you can see it right here. This is a circle with radius 2. And what we can do, we can mark it, since I drew it in black, so let's mark it right here. This is R1, so R1 equals 2. And now the challenge, of course, is to draw R2, the quadrate. So I place several angles, several values of theta, all in radian. We start with theta equals 0. Sine of 0 is 0, so R2 equals 3. So we have the point theta equals 0, R equals 3. Theta equals 0 is pointing it in the positive half of the x-axis. This is the polar axis. So if this radius of R1 is 2, I need to move one more unit away from that, and I'm right here. So at this point, this is a point in R2 in the quadrate where theta equal 0. So in the polar coordinate system, this will be the point 3, 0, sorry. R equals 3, theta equals 0. In case I said otherwise. I'm going to skip pi over 6. I'm going to go to pi over 2, which is right now is a little bit easier. Sine of pi over 2 is 1. So we have 3 plus 2. And the corresponding value of R2 is 5. So pi over 2 is upward. And this is R equals 2. This is 4. So 5 will be right here on top. So at this point, this is a point where R equals 5 and theta equals pi over 2. As you can see from this pair. So 0, 3, and then pi over 2 and 5. It's actually the way we say it. We say R theta, so we need to read it from right to left. R equals 5 and theta equals pi over 2. So we know that the quadrate will go from here at theta equals 0 to here at theta equals pi over 2. And now I can go back to pi over 6. Pi over 6 is 30 degrees, and sine of pi over 6 is 1/2. So now we have 3 plus 2 times 1/2, or 3 plus 1, or 4. So again, I read this pair from right to left. R equals 4, or R2 equals 4, theta equals pi over 6. So let's see, the radius of the inner circle is 2. I need radius of 4. I need to double the distance. This is about 30 degrees, or pi over 6. So double the distance, I'm right here. So on the quadrate, this is going to be the point that is corresponding to theta equals pi over 6. And I continue. Let's jump 5 pi over 6. We go to pi. And sine of pi, of course, is 0. So what we have is R2 equals 3. So the point here will be R equals 3, or R2 equals 3, theta equals pi. Pi is, of course, to the left. This is a distance of 2. A distance of 3 will be right here. So there is the point that corresponds to the angle theta equals pi. All right, now I think it's a good time to go back to 5 pi over 6, which is 150 degrees. So this is 90 degrees, 150 degrees about right here. It's parallel to this point. The sine of pi, 5 pi over 6, or 150 degrees, is the same as sine of 30. So it's 1/2 and back to 4. So this is going to be the point R equals 4, theta equals 5 pi over 6. The direction is right here. This is 2. I need to double the distance, so I'm right here. This is equivalent to the point on the right. So this point corresponds to theta equals 5 pi over 6. I usually draw this thing standing up. I think this point is a bit too close. I'm going to move it a little bit farther away. Yeah, there is a bit of asymmetry. This is the problem when you draw freehand, which I like to do, but it's a bigger challenge. I think this is a little bit better. So now I'm going to freehand sketch it. So this is going to be the, ooh, I missed. So this is about the correct curve. And of course the direction we are going this way because that's the direction of increasing theta. And then something similar to, oops, I missed again. Something similar to it will happen on this side. Alright, so I've drawn better cardioid than this one, but I'll have to go with what I have here. So what about to complete 7 pi over 6? This is 30 degrees beyond pi, so I'm about 30 right here, and the sign this time is negative 1/2, so we have 3 minus 1, so it will be 2. So this is where we actually meet at the circle, because this is r equals 2. So at this point I'm coming right here. Skip the 3 pi over 2, let's go to 11 pi over 6, which is negative 30 or 330 degrees. So it's about right here. Again, sine of negative 30 is negative 1/2, so 3 minus 2 times 1/2, or 3 minus 1. So we are back to 3 minus 1, which is 2. So 7 pi over 6 correspond to r equals 2, and 11 pi over 6 correspond to pi over 2, but to r equals 2. But again, r equals 2 is the same, is on the inner circle. So here we go like this, because from here we go to 2 pi, where r equals 3, because the sine equals 0. So what's left to examine is 3 pi over 2. 3 pi over 2 is downward. The sine of 3 pi over 2 is negative 1, so we're looking at 3 minus 2, 3 plus 2 times negative 1, so therefore it's 1. So 3 pi over 2 correspond to r equals 1 in this direction, so this is 2, so we are about right here. So there is a little bit of kind of a cusp here. And this is the cardioid. So we are looking at the area that is enclosed in between these two. So let's see how we're going to draw it. Let's draw it like this. So we are looking outside the circle and inside the cardioid. So what are the boundaries of integration? Well, we have R1 is the circle, and R2 is right here as the curve outside 3 plus 2 sine theta. So obviously R will be integrated from 2 to 3 plus 2 sine theta. But what about theta? On the face of it, I need to go from here to here. So let's say I didn't mark the angles. On the left, if you recall, it was after we passed pi, we went to 7 pi over 6. So theta equals 7 pi over 6 on the left. On the right, this point corresponds to theta equals 11 pi over 6. Now, I want to make life a little bit easier for me. So really, I don't need to integrate the entire region, because I see there is a symmetry about the vertical axis. The vertical axis is the same as theta equals pi over 2. So instead of integrating the entire region, I'm going to go ahead and integrate from 11 pi over 6. I need to go counterclockwise all the way to pi over 2 and then double the result because we are looking only for the area. We're not integrating some function. So instead of integrating the entire region, I'll integrate only 1/2 of the region, like so. So the region D is this. So if this is the area, the area going to be A equals twice 2D. We'll double it. I think I need more hands here. All right. So I have a comment here. So first of all, let me write what I just said. So I have a couple of comments. So the first comment, we use symmetry about the vertical axis theta equals pi over 2 to calculate 1/2 of the area. So you ask me, what is the big advantage? Well, as it turned out, when we integrate and we apply the boundary of integration, it's much nicer to apply a boundary that is theta equals pi over 2, because you know the sine we're going to give you 1 and the cosine going to give you 0, rather than apply theta equals 7 pi over 6. There is another issue. If we are going counterclockwise, notice that we're going from 11 pi over 6 to pi over 2, or if we do the entire region, we go from 11 pi over 6 to 7 pi over 6. So we are going actually backward, which gonna, with all likelihood, gonna give us a negative result. So here's I think the comment that addressed this issue. So what we're going to do, we need to maintain positive orientation of theta. In other words, we need to go from counterclockwise, and we'd like to go from low value to high value. So instead of going from 11 pi over 6 to pi over 2, which is actually going from high to low, I will replace 11 pi over 6 with its equivalent. 11 pi over 6 is the same as, so let me write it here, is the same as negative pi over 6. And I'll use that angle. So I'll go from negative pi over 6 to pi over 2. So this way I'm going to move forward. So let's say we maintain positive orientation of theta. Let me underline positive orientation. This is something we need to remember. By replacing theta equals theta equals 11 pi over 6 with theta, and this is theta 1. We're going to go from theta 1 to theta 2. With theta 1 equals negative pi over 6. Let's box it. So now the boundaries of theta will be the following. We're going to say that theta runs from negative pi over 6 to pi over 2. So at least pi over 2 will be a little bit easier to evaluate. So let's see what is the region D in the way we write it. So D will be the set of all points in R theta, such that we establish that theta runs from negative pi over 6 to positive pi over 2. What about R? Well, R will run from, let's see, the lower boundary. We're going to go from 2 to the cardioid, from the circle to the cardioid. Well, the circle is 2, and the cardioid will be 3 plus 2 sine theta. And here's where we win the battle, just by setting the boundaries in a proper manner. All right, so the area, now we can write the area equals, we double it, so it will be twice the double integral. So theta going to run from negative pi over 6 to pi over 2, and then we integrate with respect to r. So r runs from 2 to 3 plus 2 sine theta. When we integrate the area, we integrate 1. Remember, this is, we integrate dA, and dA is r dr d theta. So r dr will be part of the inner integral, and then we close the bracket and we integrate d theta outside. So the first thing we need to do, we integrate r. So we have r squared over 2. So we have the 2 and the 1/2, they cancel each other. So 2 times 1/2 r squared. So outside we're still going to have the integral from negative pi over 6 to pi over 2. And the result of the integration with respect to r is r squared. Again, we have 2 times 1/2 r squared. And then we evaluate r from 2. So r runs from 2 to 3 plus 2 sine theta. And after we've done with this, we will go ahead and integrate with respect to d theta. All right, so we evaluate it. So this equals to the integral from negative pi over 6 to pi over 2. And now we evaluate r squared, so we do have the following. We have 3 plus 2 sine theta squared, and then minus 4 d theta. So this is what we need to integrate. So let's see, we have 3 squared plus let's see. So some of it we can limit. So we have 3 squared 9 minus 4, that will be 5, right? So we have 5. And then we do have 3 times 2, 6 times 2. So we have 12 sine theta. That will be the middle term, 12 sine theta. And then we have plus 4 sine squared of theta, right? But instead of sine squared of theta, I can replace it with the half angle identity. So I'll write it. So let me change this bracket to curly bracket, because instead of 4 sine squared, I have 4 times, and it will be 1/2, if you recall. So it will be 4 times 1/2. Let me put it in between. 4 times 1/2. And then sine squared is 1 minus cosine 2 theta. And with that, I can close the bracket and integrate with respect to d theta. Okay, so let me go to my second paper and continue. So let's say in class I put it side by side. I'll try to do it the same way here. See if this will work. Again, I'm doing it sitting down. I'm not used to do stuff sitting down. So the area, if I'll continue here, equals. So let's see if we can clean this up, the integrand. So we have the integral from negative pi over 6 to positive pi over 2. And let's see, we have 5. We have 5 plus 2 from here. 4 times 1/2, so we have 7. We have 12 sine theta, that does not change. So plus 12 sine theta. And let's see what we have here. We have 2 times cosine 2 theta. So, and it's negative. So we have minus 2 cosine 2 theta. And we can close the bracket, and now we are ready to integrate. So at this point, we just have this relatively simple integral. So we have 7 theta. The antiderivative of 12 sine theta is negative 12 cosine theta. And here we have negative 2. The antiderivative of negative cosine theta is negative sine theta. But we have 2 theta, so it will be 2 times 1/2. So it will be simply minus sine of 2 theta. And now we need to evaluate this from negative pi over 6 to positive pi over 2. So what I'll do, well, I have 7, so pi over 2 minus negative pi over 6. So 7 will multiply pi over 2 plus pi over 6. We have minus 12. Well, cosine pi over 2, which is 0, minus cosine of negative pi over 6. And then here we have minus sine of 2 pi over 2, so sine of pi minus sine of 2 times negative pi over 6, so sine of negative pi over 3. So at this point, I'm still on page. I can go ahead and check what are the values. So cosine of pi over 2, this is a 0. Sine of pi is 0, so we took care of business here. The cosine function is an even function. So cosine of negative argument is the same as the cosine of positive argument. So the cosine of negative pi over 6 is the same as cosine of positive pi over 6. It's the same as cosine of 30 degrees. So it's if in case you forgot, it's square root of 3 over 2. So here we have square root of 3 over 2. And again, cosine of negative is the same as cosine of positive. And now sine of negative pi over 6 is negative sine of positive pi over 6 because sine is an odd function. So this one equals negative, and pi over 6 is 1/2, so it's going to be negative 1/2. I'm sorry, sine of pi over 6 is 1/2. So sine of negative pi over 6 is negative 1/2. So now I'm going to put all the values together. Pi over 2 is 3 pi over 6, so we have 4 pi over 6. So no, it's positive, sorry. So what do we have? We have 3 pi over 6 plus pi over 6, so we have 4 pi over 6, but times 7. So 7 times 4 is 28, divided by 6, we can reduce it to 14 over 3. 28 over 6 is the same as 14 over 3. So we have 14 pi over 3. This is the first term. We have negative 12 times the negative square root of 3 over 2, so it will be positive 12 over square root of 2. Or positive 12 times 3, sorry, positive 12 times square root of 3 over 2. I'll reduce it later to 6 times square root of 3. And then here we have negative, and there is a negative here, so it's positive, but there is another negative up front. So we have triple negative, negative here, negative here, negative here. Let me put this negative like so. So we are clear that this does not include this negative. So we still, the answer is negative 1. This is pi over 3. It's not pi over 6, it's double. I knew that something doesn't look right. I wasn't clear. I thought I didn't see 6. So sine of pi over 3 is square root of 3 over 2. It's not 1/2. Okay. So negative, negative, negative. We have negative, and there is no multiplier here, so negative square root of 3 over 2. So what is the solution? So actually, here's the reason why I did not reduce it to 6, because I know that I'm subtract 1/2. So at the end, we have 14 pi over 3. Let me write it a bit clearer. And then plus 11 times square root of 3 over 2. And this is the area. Remember, you already multiply the 1/2 by 2 earlier in the integration. And there it is. Took me much longer than I thought, but that's one of the reasons I couldn't do it in class, because this takes quite a long time.